In section 7.3, we start to add and subtract fractions. The good news is everything in here has a common denominator to begin with when we're doing the addition and subtraction. The second half of the lesson looks at how to find those common denominators so that as we move towards 7.4, when we're doing addition and subtraction with unlike denominators, we know the process to make them look like they do in the first half of this lecture. So we're going to figure out how to add and subtract rational expressions with the same denominator, how to find the least common denominator, and how to build rational expressions into equivalent expressions that use that least common denominator. In this section, we extend the rules for adding and subtraction numerical fractions to problems involving addition and subtraction of rational expressions. So, if we had just regular fractions with the same denominator, like 3 over 7 plus 2 over 7, basically what we do is we add the tops and keep them over that same bottom. Same idea with subtraction, we subtract the tops and keep them over that same bottom. If I reduce here, 3 plus 2 gives me 5 over 7. 3 minus 2 gives me 1 over 7. So the general idea is if D is the same in these rational expressions, A over D plus B over D gives me A plus B over D. A over D minus B over D gives me A minus B over D. So we're going to look at a couple examples here. X over 8 plus 3x over 8 and 3x plus y over 5x plus x plus y over 5x. Because the rational expressions have the same denominator, we're just going to add the numerators and then write the sum over the common denominator. But we do want to be on the lookout to see if anything reduces the way that it did in 7.1. So here when we do x over 8 plus 3x over 8, we keep it over the same common denominator and add the tops. Since these are like terms, we can combine x and 3x to get 4x over 8. We now need to say, is there anything that goes evenly into 4x and 8? There is. 4 goes into both. That's why this becomes x over 2 when we reduce. Here, when we combine 3x plus y plus x plus y over 5x, we see the like terms are this 3x and this x, this y and this y. So it becomes 4x plus 2y over 5x. At this point, there's no way to reduce that. We have to leave it as is. Remember, I can't reduce an x here and an x here because I have an addition symbol on top. I can only reduce things that are being multiplied. So if I could take an x out of both these terms, pull it out front as a factor being multiplied, then I could reduce it with this x on bottom. But I absolutely cannot reduce these x's like this. These example problems I'm going to do out on the whiteboard, so I'm going to wave to myself to let myself know to cut in the whiteboard. So in these problems, I begin by keeping the same denominator, x plus 4. I then combine the two things I had on top, 5x plus 20. Almost always in these problems, there's going to be a way to reduce. In this case, on top, I can take a common factor of 5 out. If I divide 5x by 5, I get x. If I divide 20 by 5, I get 4. I then have 5 times x plus 4 over x plus 4, meaning I can get rid of this factor of x plus 4 to make it 5 over 1, or just equal 5. Same idea for the second problem. I keep that common denominator of 3x minus 1. This becomes negative 9x plus 3 on top. I can take a negative 3 out of each of those. If I take out a negative 3, negative 9x divided by negative 3 gives me positive 3x. Positive 3 divided by negative 3 gives me negative 1. So I have the same thing on bottom, on top, as that repeated factor, which leaves me with negative 3 over 1, or just negative 3. Here when I have the subtraction sign, I always want to be careful that subtraction is applied to everything on top. Since there's only one term, it's not so bad, it just applies to that one. So here, the x minus 1 stays on bottom, this becomes x squared minus 1. But then I realize, wait, x squared minus 1, I know how to factor that, that's a difference of squares. it's going to become x plus 1 times x minus 1, still over x minus 1. When I then reduce that factor, it becomes x plus 1 over 1, or just x plus 1. Write the common denominator, x plus 3. Write the first term, x squared plus x, then minus 6. I now see the top is a trinomial that can be factored. Specifically, it can be factored into x plus 3, x minus 2. On bottom, we already had an x plus 3, so when that factor goes away, we're left with x minus 2 over 1, which just becomes x minus 2. The least common denominator. Basically, if we had 4/7 and 3/5, we wouldn't be able to combine them because they're not over the same number. We want to find a way to express them so that they are over the same number. So basically, if we factor each denominator completely, then we can find the LCD by finding the product of all the unique factors that are in the two numbers we're trying to find the common denominator between. We don't need to repeat any of the factors that are already there. The LCD is a product that uses each different factor obtained in step 1 the greatest number of times it appears in any one factorization. So if we want to find the LCD of a pair of rational expressions like 11 over 8x and 7 over 18x squared, or like 20 over x and 4x over x minus 9. The way that we do the process is we're going to factor completely the denominator of each, and then we're going to form a product using the factor, each factor, the greatest number of times it appears in any one factorization. So if we factor 8x, it becomes 2 times 2 times 2 times x. If we factor 18x squared, it becomes 2 times 3 times 3 times x. So what we can see is that they both already have this 2, they both already have this x. But we need this additional 2, this additional 2, this additional 3, this additional 3, and this additional x to make sure everything is covered. What that means is that we're going to take out 2 times 2 times 2 times 3 times 3 times x. When I multiply it all out, I get 72x squared. Just to go back to show where that comes from, really what's happening here is we're doing 2 times 2 times 2 times x. We're skipping that 2 because we already had it up here. Now we're multiplying by 3, we're skipping that x because we had it up here. Now we're multiplying by x. X times x gives me x squared. 2 times 2 times 2 gives me 8. Times 3 is 24. Times 3 is 72. So that's really where they're getting that 72x squared. The LCD for 11 over 8x and 7 over 18x squared is 72x squared. Notice we're not concerning ourselves with the numerators yet. Those will be important when we do the last step in this lesson, which is trying to find equivalent expressions. They'll also be important in the next lesson about finding addition and subtraction with unlike denominators. But for now, we're really just trying in these problems to identify what would be the common denominator. Since the denominators of 20 over x and 4x over x minus 9 are completely factored, the factor x appears once here, the factor x minus 9 appears once here. I need both of them. So the LCD is going to be this factor x times this factor x minus 9. If they were things that I had to factor, like let's say they were a difference of squares problem versus a trinomial, if they had a repeated factor, I would only need to list that factor once in the least common denominator. Here's a few problems that I'm going to try. Again, I'm going to wave to myself on the whiteboard to let me know to get started, and then cut back in with the lecture. And we're back. When I go to find the least common denominator between these two terms, I need to look for the highest power of x when they're monomials like this. When I say they're monomials, what I'm really looking at is the terms on bottom of the fractions. The tops will matter when we end up having to combine them. We'll have to multiply by something. But in this exercise, I'm really concerning myself with the bottoms and saying, what could I use to make the two bottoms look the same? So whenever I find an LCD, When it's got one term on bottom like this, I look for the highest power of x, and that has to be included. So here I have the single power of x, I have x squared, highest power of x I see is x squared. I then look at the numbers 3 and 9, and I say, what's the least common multiple between them? If I wrote out the factors of 3, it'd be 3, 6, 9. If I wrote out the factors of 9, it'd be 9, 18, 27. I could keep going if I had to, but this is as far as I need to go to see the overlap of 9. If I made this 9x squared on bottom, basically I'd multiply this first fraction by x over x. 9x times x would get me to this 9x squared. I'd multiply the second fraction by 3 over 3. 3 times 3x squared would also get me to 9x squared. So I have a way of converting both of these fractions so that they're over this common denominator. That means the answer to this question is 9x squared. When I have factors like this, x minus 2 and x plus 5, the only way to create a common denominator is by multiplying the two factors, x minus 2 times x plus 5. In this case, this would get multiplied by x plus 5 over x plus 5. This would get multiplied by x minus 2 over x minus 2. For problem 3, really I want to factor the bottoms before I consider what they have in common and what they don't have in common. So for x squared plus 9x, I can pull an x out, and that leaves me with x plus 9. For x squared minus 81, hopefully I see it as a difference of squares, x plus 9, x minus 9. What I now see is that there's the repeated factor of x plus 9. Since it occurs in both of the two denominators, I only have to include it once, not twice, in my common denominator. So my common denominator needs to include everything. It needs to include this x plus 9, this x minus 9, but notice I didn't rewrite this x plus 9 because it was already there. So to create this common denominator, I'd have to multiply the first term by x minus 9 over x minus 9. I'd have to multiply the second term by x over x. That way, both of the bottoms would be x times x plus 9 times x minus 9. Again, we're not really concerning ourselves with what happens on top yet. We're just writing what this common denominator would be. So the common denominator for number 2 would be x minus 2, x plus 5. The common denominator for number 3 would be x times x plus 9 times x minus 9. Build rational expressions into equivalent expressions. So the idea here is to start with something that doesn't have the correct least common denominator, multiply by something over itself to get it to the denominator that we've been given. So if, for instance, I wanted to write 3/5 as an equivalent fraction over 35, to get from 5 to 35, I'd have to multiply by 7. So I'd want to multiply my 3/5 by 7 over 7. I then get 21 over 35, which is absolutely equal to 3/5, but is written now over 35, so that I can combine it with something else that had a denominator of 35. To add and subtract rational expressions with different denominators, we must write them as equivalent expressions with the same denominator. So to build rational expression, multiply it by 1 in the form of c over c, so multiply by something over itself, so that I haven't actually changed the fraction. Let's say, for instance, that I had 7 over 15n and I wanted the denominator 30n cubed, or 6x over x plus 4, I wanted the denominator x plus 4x minus 4. The way to figure out what to multiply by is really to take what's currently on bottom, take what they want your denominator to be, and divide what they want it to be by what's currently there. What they want it to be by what's currently there. If I divide 30n cubed by 15n, 30 divided by 15 gives me 2. N to the third divided by n gives me n squared. So if I multiplied this by 2n squared over 2n squared, it would get me to the proper common denominator. Same idea here. If I divided x plus 4x minus 4 by x plus 4, these would go away and just leave me with x minus 4, meaning I need to multiply this by x minus 4 over x minus 4 to have the denominator indicated. So we begin by asking, by what must we multiply the given denominator to get the required denominator? Again, I can do this by just dividing. If I divide 30n cubed by 15n, that's really where I get this 2n squared. Once I know that the 2n squared will get me to my common denominator, I multiply by it over itself. On top, 7 times 2n squared gives me 7 times 2 is 14, and then the n squared. On bottom, 15n times 2n squared gives me 30n cubed, which was what we were given as the common denominator we wanted to get to. Same idea for this x plus 4 problem. We found out when we divided that x minus 4 was what was left over, so we're multiplying by x minus 4 over x minus 4. That leaves me on top with 6x times x minus 4, on bottom with x plus 4 times x minus 4. You can multiply these out. Again, I'm not exactly sure in the system which way they'll accept. I hope that they'd accept it if you just left it right here, but they might need you to go the extra step. These last 3 problems, again, I'm going to do on a whiteboard, where I'm going to show you how to find the common denominator and then what it would equal as an equivalent expression. When we want to create one of these common denominators, basically it means we want to take what was here, multiply it by something to get it to here. So I'm only looking at the bottom and saying, how do I change the bottom from 7x squared to 35x to the 5th? Really the way to do this is to divide. So if I take 35x to the 5th and I divide it by 7x squared, 35 divided by 7 would give me 5. X to the 5th divided by x to the 2nd would give me x to the 5 minus 2, or x to the 3rd. What that tells me is I'm going to need to multiply top and bottom of this equation by 5x to the 3rd. If I do that, what used to be 6 over 7x to the 2nd times 5x to the 3rd over itself 5x to the 3rd. On top, 5 times 6 gives me 30x to the 3rd. On bottom, 5 times 7 gives me 35. X to the 2nd times x to the 3rd becomes x to the 2 plus 3, or x to the 5th. So if I want to write an equivalent fraction to this over this common denominator of 35x to the 5th, I would multiply top and bottom by 5x to the 3rd to get 30x to the 3rd over 35x to the 5th. Applying the same process to this problem with all variables, basically I take what I want the common denominator to be, x squared minus x. I divide by the current denominator, x. X squared divided by x is going to give me x. Or negative x divided by x is going to give me negative 1. So this tells me I'm going to need to multiply top and bottom by x minus 1. So if I take what used to be x plus 1 over x, and I multiply it by x minus 1 over x minus 1. On top, x times x gives me x squared. Positive 1x and negative 1x cancel each other out. Positive 1 times negative 1 gives me negative 1. So all that's happening there is really, it's a difference of squares when I multiply it out. On bottom, x times x minus 1, x times x gives me x squared. X times negative 1 gives me negative x. So I went from something that had an x on bottom to now the denominator that I wanted, x squared minus x, by multiplying by x minus 1 over x minus 1. When we get to problem 3, we want a denominator of x plus 7, x minus 2. If I take that denominator we want, x plus 7, x minus 2, and I divide it by the current denominator, x plus 7, you'll see that what's left is an x minus 2 that we're going to have to multiply top and bottom by. So we write the equation, 3x over x plus 7. Sorry, I didn't love that plus. So x plus 7, we're going to multiply it by x minus 2 over x minus 2. That way the bottom of our fraction is what we wanted, x plus 7 times x minus 2. On top, I'm going to do out the distribution. 3x times x gives me 3x squared. 3x times negative 2 gives me negative 6x.